Hi everyone, what's up? I hope you are doing well. Uh, Today, we continue to complete our linked list. The last time we succeed to create push to the front and pop from the front. Okay, so we need to continue uh, use these two methods to push to the back, also pop from the back. Okay, we need small changes to complete these two uh, methods. So let's do it. We need to duplicate the our method, okay, and push. We rename it to push back. We need the small changes. For example, we need to node next point to the none, and previous one needs to point to the head. Okay, this line is the same, but we need to check the tail instead of the head. Okay, so replace with the tail, and if the tail none, we need to head point to the node. Okay, and instead of the head, we rename it to tail. We replace it here, and instead of the previous, we need to replace it with the next and node. Here we change it to the tail. Okay, our pushback is completed. What about pop? Okay, let's create for pop. We need to duplicate this method. We can say pop from back. So instead of the head, we need to map to the tail. And here, instead of head, we replace it with a tail. Node next become previous, and instead of the head, we need the tail. Of course, we need to change to the head here. Also here to the tail, and tail, we change the tail and the next. So we decrease and return a node. I also need this method. Okay, pop back, and also here. Okay, that was easy. We replace our we create our method for push and pop for back of the list, and let's continue. We create a test at the end of the video, but we need to create another method for searching our entire list. What now? Okay, the next method we are going to create is contains. We are going to walk through entire list to find the element. If the element exists in our list, we return a true. If doesn't exist, we return a false instead. Okay, let's do it. For compare generic elements in our list, we need to partial equal trait. So if we create another implementation for our list is would be better. So we are going to do that. Implement T for our list, where T is use partial equal. Okay, so we need a method for search, our search, when contains and E, or let's say elements, very useful, and return a bool. Okay, so for walking through our release, we need a multiple copy from the head, because we are going to start from the head to walk through entire list. So let's do it. Let's create a mode copy from our list. So sorry, we need a self here and must be mode self. Okay, we use a while loop, while let sum to walk through our list. It's easy. Use a while let sum. Let's say we need a node mutable because we're going to some changes on the node current, and we need to check our node with our element. Okay, so it's unsafe because we use as a reference to access the next element and put them to the current list, because we need to walk through entire list. So current is going to be node as a ref is unsafe. Okay, next, and we check the node as a mut, and we access the element here, and we compare with our element, and if exists, return true, and here we return a false. Yeah, that's it. It's really easy to create, to walk through to the linked list. Okay, the next method we are going to work with is move to the front, as I promised. This is a 3-level working because you need the first walk through to the entire list, find the element. Next, you need to remove the link from the previous and next. Then you need to push that element to the front. Okay, let's do it. I think that's enough for this video. In the next video, we are continuing to complete our move to the front. I hope you enjoy. Have a good day. Bye.